Dear all, so in this video session, we'll be learning about multivibrators. So it is a waveform generating circuit. Multivibrators are also called as regenerative circuits. It is similar to that of the skimmed trigger, what you have studied in Unit 2. This multivibrator is used to produce a square wave or pulses. There are three types of multivibrator: astable multivibrator, monostable multivibrator, and bistable multivibrator. A stable multivibrator is that it produces a square waveform and it does not have any stable state in it. It is also called as free running multivibrator. What is a stable state is that in a square waveform you will have two states. One is positive VSAT, the other one is negative VSAT. So you will have two values, plus and minus. So these are called as states. So in a stable multivibrator, the transition will from positive to negative will happen as it is. You don't need to give any triggering signal. Hence the name free running multivibrator. The second multivibrator is monostable multivibrator. Monostable multivibrator, here one state will be stable, the other state is quasi-stable. So when I need to move from stable state to the other unstable state, I need to give an external trigger pulse for the shift. This is also called as one-shot multivibrator. The third one is bistable multivibrator. Here both the states are stable. So when I need a transition, I have to give a pulse for every transition. Hence the name bistable multivibrator. So in this session, we'll be learning about a stable multivibrator and its working. The circuit diagram of a stable multivibrator is given in the slide. It is similar to that of a skimmed trigger. You can see there is a potential divider circuit R1, R2. This feedbacks the output voltage to the positive terminal. At the negative terminal, you are connecting a capacitor and it is grounded. A feedback resistance is connected between the negative terminal and the output through the resistance R. So here at the positive terminal, what happens is that when my output voltage is VSAT, a portion of that VSAT will be fed back to the third terminal. That portion is given as beta. So beta is the potential division of the voltage. Now let me see how the working is going to happen. So let me assume the output voltage is VSAT. The capacitor is initially charged to a value of minus beta VSAT. Available in capacitor is minus beta VSAT. So when the output is VSAT, a portion of that voltage is fed back to the third terminal, that is beta VSAT. So that beta VSAT is appearing at the third terminal. The same voltage will appear at the second terminal by virtual ground. Now this voltage is positive. So what happens is that the capacitor will try to charge to this positive voltage. So capacitor, you can see here, the capacitor is charging from minus beta VSAT and it is continuously charging towards plus beta VSAT. It will try to charge till VSAT. Once the capacitor voltage reaches beta VSAT and it becomes greater than beta VSAT, second pin voltage will be greater than third pin voltage. So when second pin voltage becomes greater, the voltage is getting toggled. Here it is plus, now it becomes minus. So plus VSAT 2, it becomes minus VSAT. You can see the toggle here. Now the voltage here is minus VSAT. That voltage is fed back again. Now the feedback voltage is minus beta into VSAT. So the second pin terminal will be minus beta VSAT. Now the capacitor will try to discharge from positive voltage, it try to discharge to the negative voltage. So it will discharge from beta VSAT to minus beta VSAT. Continuously discharge will be happening. Once the voltage becomes lesser than this third pin voltage, the voltage again toggles from minus VSAT to plus VSAT. You can see the toggle. So this process will be continuously happening and the toggling is based on the charging and discharging of your capacitor. So you can see that a square wave is generated and the capacitor charging and discharging is happening according to the voltage that is fed back. So now let me derive the expression of the pulse width. This is based on the capacitor voltage. The capacitor voltage is given as Vc of t, that is equal to final value of the voltage plus of initial value minus final value t power minus t by RC. So here, the final value to which the capacitor is going to charge is plus Vsat. The initial value is minus beta Vsat. I substitute these two values in my expression. So you'll have Vsat minus beta Vsat minus Vsat e power minus t by RC. Now, you can see I further simplify the expression. At T1, T1 is the pulse width of the positive wave. At T1, your capacitor voltage final value is beta Vsat. I substitute it over here in the expression, in the capacitor voltage expression. I try to cancel Vsat and Vsat and I try to simplify this expression. On simplification, I find out what is the value of T1, that is the pulse width. T1 becomes RC ln of 1 plus beta divided by 1 minus beta. Beta is the potential division that is given by R2 divided by R1 plus R2. I substitute instead of beta R2 divided by R1 plus R2 and I simplify. I get my expression as RC ln of R1 plus 2R2 divided by R1. So here this is the value of your positive pulse. Your negative pulse will also have the same value. So total time period T will be equal to 2 times T1. So 2 times RC ln of 1 plus beta divided by 1 minus beta. Now to find out the frequency of oscillation will be equal to 1 by time period. So 1 by 2 RC ln of 1 plus beta divided by 1 minus beta. From this I find out what is the frequency, that is equal to 1 by 2.2 RC. So this is the frequency of the waveform that is produced by an astable multivibrator. So you could understand how an astable multivibrator is going to work with the help of this video session. Thank you.